Hello and welcome to Maths with Matthew. Hope you find this video useful and helpful. And apologies for the setup, the screen, all this screen moving about quite a bit. You know, changing how it looks throughout the video. It's because this is the first one, and I wasn't sure on how to record it at the beginning. But here we are now. It's probably just going to be like this as time progresses. But yeah, I hope you enjoy. Okay, so we're going to start with this question. Sketch the graph of y equals 2x squared minus 8x minus 5. I just like to write the question out before I do anything. Showing the coordinates of the turning point. Okay, so that's when we're at the bottom of the parabola, when the gradient is 0. The exact coordinates of any intercepts with the coordinate axis. It's a terrible line. Give me a sec. Okay, so that's when it intercepts the y and x axis, when the curve. So here, here, and here it would be. Twice on the x-axis, because this is what the parabola looks like, and once on the y-axis. Okay, so I think the easiest thing to do first would be to find out where it intersects the y-axis. So that is when x is equal to 0. Because notice that is going to be when this x coordinate here is 0. It's going to be right on the y-axis. Okay, so we're going to plug that into our equation, or our function for the line, the graph of the line. So here we go. And then notice, because these terms are being times by 0, they get cancelled out, and we're just left with y equals minus 5. Alright, and I'm going to put a red box around that, so we know that that's one of our answers. Okay, so now we've done that, we're going to work out where it crosses the x-axis. Okay, so we've done the y-axis, now we're going to work out where it crosses the x-axis. So that is when y equals 0. So we're going to say this time that 0 equals 2x squared minus 8x minus 5. And this is a quadratic equation. So the way I like to do it without a calculator is completing the square, because that's the way I'm going to do it. So I'm going to say that 0 equals x squared minus 4x minus 5 over 2. Okay, and then I'm going to say that x minus 2 squared minus 4 minus 5 over 2 is equal to 0. Quick interlude, post-commentary, Matthew here, just telling you that I actually recorded a bonus clip at the end of this video that'll tell you how to complete the square. So I got you covered, you don't need to go anywhere else. Stay here, please. Thank you. Just converted that 4 into minus 8 over 2, so it's easier for me to combine these to 13 over 2. So I hope you can see how we've gotten this. Now that we're at this point, we're going to get our two values, because notice there's two values because of the nature of parabolas. Okay, so x minus 2 is equal to plus or minus 13 over 2. The square root of plus or minus the square root of 13 over 2, that is. And that is because, notice if this was negative, right, if you have like negative 2, right, and negative 2 squared is equal to 4, and 2 squared is equal to 4. Okay, so it's impossible to know if, when we take the square root of this value, whether it was negative or positive. So that's why it can be plus or minus. And that gives us our two values. So that means, sorry, I've written that again. X is equal to 2 plus root 13 over 2, or X is equal to 2 minus root 13 over 2. And those are our two values. I'm going to put that in a red box again. Those are our two values for X. Lovely. Okay, now that we've done that, I'm going to work out the X coordinate. We're going to work out where the turning point is, right? And how I'm going to do that is I'm going to work out the X coordinate and then plug it back into the equation. And because of how parabolas work, they're completely symmetrical, right? So if I draw another axis here, I draw a parabola on it. There's a line of symmetry here. And that line of symmetry always goes through the turning point. And because we have two values here on the same x-axis or the same y-axis, the average of these two x values is going to be the middle, where the x coordinate of the turning point is. Okay, so let me just get rid of all this rubbish here, and then let me just say, so to work out the average, we have to add them together and divide by 2, which looks hard because of all these roots, but they all cancel out, which is very nice for us. So because these roots are plus and minus, they cancel out, and then over 2, which is equal to 4 over 2, which is equal to 2. So then that means that the x coordinate So that means that the x co-ordinate is equal to 2 for the turning point. Right. And then how we work out the exact coordinates, so here it wants the exact coordinates, by plugging the x equals 2 into the original equation. And by working that out, 2 squared is 4 times 2 is 8 minus, oh sorry, this should be 2. So, sorry, let's do that again. So 2 squared is 4 times 2 is 8 minus 16 is minus 8 minus 5 is minus 13. So y is equal to minus 13. So the coordinates for the turning point, so that I'm going to write TP equals 2 minus 13. I'm going to box that. Okay, so last thing we have to do in this question is draw the coordinates here. See if I can do an alright job at this. Wait, so over here. And the coordinates you work out here don't have to be exactly like in the place relative to the graph. It just needs to be like a rough estimate with these points on. So there's one about here, y-intercept here, and the turning point here. And I'm just gonna connect these up with a line. It's very hard to do on the computer, so bear with me here. Make sure this bottom bit isn't as like V-shaped as mine, so they know it's like a U. Like a bit like this one over here, that's a bit slightly exaggerated, but... And make sure it goes through all the points too. Anyway, and then just write the points on. So this one is 2 minus 13. This one is 0 minus 5. And this one is 2 plus root 13 over 2. Oh Christ. Over 2. 0. Don't forget the y. the y point, and then this is 2 minus root 13 over 2, 0. And that's it. That's how you do that question. Happy? Okay, so this is another question that is this time more about translations than coordinate geometry. So if we read the question here, it says the graph of y equals x cubed plus 6 is translated 4 units to the right. The translated graph has equation y equals f of x, and we want to work out what this f of x is, or what this part is after it's been translated 4 units to the right. Okay. So that if we're looking at coordinates, a coordinates like this, we're translating this way, okay? And when we translate that way, we're translating in the x direction, so we're translating in the x direction 4 units. 1, 2, 3, 4. Okay, and the way we do that is we take our original function, so y equals x cubed plus 6, and then to all these x's we minus 4. So then we have our new graph, I'll call it f of x because that's what they do in the question. F of x equals x minus 4 cubed plus 6. And that's what our new equation is going to be, our new line is going to be, or a new curve is going to be, should I say. Okay, now it looks counterintuitive that, well, we're moving in the positive x direction, why are we taking away 4? And to that, I would say that is how, secretly, that is how all functions work, right? And I'm going to explain that by giving you a different example. So if I say that y, let's just use the same curve. So y equals x cubed plus 6, okay? And I want to move this up. I want to move this up 3 units. And you would say, well, to do that, I would just do plus 3 at the end, because I'm moving it up 3. And you're like, well, that's not a minus, that's a plus, and that's how it should be. But no, because if I'm doing it next to the y, because I'm moving it up 3 in the y value, if I'm doing it next to the y, like you do it next to the x when you're doing x, it's actually y minus 3, because there's a translation, y minus 3 plus x cubed plus 6. And there you go. There's another minus, counterintuitive. And then that works out to be this, which is what we want. So let's not get sidetracked anymore, and let's go back to the actual question. So we want to translate 4 units to the right. Hope that explanation made sense of why we do use the minus instead of the plus for the positive direction. Okay, and then you'd be like, oh, well, that's great, we've done that, but it wants it in the form, in that form there. Okay, now let's do that. So I'm just going to move this over here. And the way I like to, so we have to expand this cubed. The way I like to do that is just by writing it out 3 times. It just means I can keep track of it more. Plus 6 on the end. So we have that. And now the method I like to use to cross multiply out these brackets is by looking at this x, right? By just going from the left and going all the way to the right. Okay, and I do that because it's really systematic, and then usually if I keep it a certain method and I never change that method, then you'll rarely make a mistake. Okay, so this is the method I use. You don't have to use this method. This is just the one I use. So I do this x and I times it by this one, then I times it by the minus 4. Then I look at the minus 4 and I times it by the x and times it by the minus 4. So let's put that into practice. So x squared, x times x, and then x times minus 4 is minus 4x, and then onto the minus 4, minus 4 times x is minus 4x again, and then minus 4 times minus 4 is plus 16. Okay, and then we have the other, and I just stopped there because it's too hard doing all of it at once. And now I'm gonna, because we can do this as well, because you know, multiplication is, you can do it wherever and it doesn't matter. Hopefully you know what I mean by that. Like, you can't just shove multiplications in whenever, but I mean, you could, if you had like 3 times 2 times 1, it's the same as 1 times 2 times 3, if you know what I mean. Okay, let's get rid of that now before I make a fool of myself. So now I'm just going to do the exact same thing with this next, with these next brackets. So then x squared times x is x cubed, x squared times minus 4 is minus 4x squared, minus 8 times x is minus 8x squared, minus 8x times minus 4 is plus 32x, 16 times x is plus 16x, 16 plus minus 4 is minus 64, and then don't forget the add 6 on the end. Okay, now let's simplify this. That's just x cubed. Then these simplify to minus 12x squared. These add together to plus 48x. And then these add together to minus 58. And there you go. That is your final answer. Doing a little blue box. Lovely. Okay, so this is the last question. This time it involves inequalities. Okay, so it says sketch the curve. Oh, here is a sketch of the curve of that, and it's been very helpful, giving us a nice sketch of the curve of y equals x squared plus 4x minus 12. There it is. Work out the values of x for which x squared plus 4x minus 12 is less than 0. Give your answer as an inequality. So this here, I want you to notice, is the same as this one up here, right? So that means that we can say that we want the values of x. So we want values. I'm just going to clarify the question a bit. So values of x, that values of x that for when y is less than 0, right? So the values of x for when the y is less than 0. So that's all these values under the x, under the x-axis, is when y is less than 0, right? So those are going to be the values of x within this region of the curve. There we go. So we want an inequality of all these values of x. Right. So let's do that. So we want to solve x squared plus 4x minus 12 is less than 0. We want all those values less than 0. And I'm going to complete the square here. Okay, we've done that. And now it's just a matter of solving this. Okay, so I've just brought all those over to that side. I'm now going to square root both sides, and this is where the inequalities get a bit tricky. So when we do that, we're obviously going to get 2 answers. Okay, so so we can say that x plus 2 is less than 4. And we can also say that x plus 2 this time is greater than minus 4. And because this one's the minus, the sign switches. Okay. And then we can simplify that further into x is less than 2. and then x is greater than minus 6. And that's our answer there. But we can simplify this further into just one equality. So I'm going to do that now. So I'm going to say that minus 6 is less than x, which is less than 2. And I've basically just combined these inequalities together to give us this in a black box this time for my answer. And there it is. Last question of the day. Okay, so as you can probably see by what's on the screen, we've got a bonus at the end, and I'm going to show you how to complete the square. Okay? So let's do that. To complete this, right, so first, what I'm going to do first is I'm going to just show you a few examples, and then I'm going to like show you the proof behind it. You don't have to watch the proof bit if you want, but I think it's interesting. Anyway, so I'm going to show you some examples here. Let me just make something like that. Okay, there we go. And what we're going to do is we're going to complete the square on this. So as I say, I'm just going to tell you how to do it here, and then I'm going to show you why it works later on. Okay, so this is the example. So to complete the square, we want to take this bit, right, and just say that x plus a half of whatever this value is here. So plus a half of 3, so 3 over 2, right? And put that in brackets, squared, right? And that's going to be the first part of this, right? So that's squared, and then we're just going to minus whatever this value squared is at the side. So that would be 9 over 4. And then we're just going to add the 4 over here. And that's how you complete the square, right? And this is very useful because, well, this is obviously, so then basically we can say that that is equivalent to the first thing up here, which it is. Okay, this is equivalent to this. And this is useful because now in this side of the equation we only have one x, but there's like multiple x's over here, so it's hard to do anything with. But with this, we can work with this and then solve equations much easier. So now I can solve this equation much easier just by moving everything over here, square rooting that, and then minusing 3 over 2, and that's what the value of x is. So it can be very, let me just do that. Oh, alright. I can't be arsed actually working out what this is. So let me just. Alright, so this square plus or minus the square root of 9 over 4 minus 4. Hopefully I haven't made a mistake there. Minus 3 over 2. Alright, and then there we go, that's x. Like, you can plug that in the calculator or you can work that out, and there you go. That's the value, that's both your values of x, and it's very useful. Anyway, that's the method I use to solve equations if I don't have a calculator, or to solve quadratic equations if I don't have a calculator. I just think it's very handy. Okay, so now I'm going to show you why it works. So I'm going to write out a more generalized version of the first equation that I wrote up before. So x squared plus bx plus c equals 0. Okay, and there's a quadratic equation. Okay, so basically what I'm going to do is I'm going to start with something and then try and mold it into this. Okay, let's do that. Okay, so I'm going to start with x plus b squared, and that equals x squared plus 2bx plus b squared. And if you don't believe me, I will do the little method I did earlier on in the video to multiply out brackets. X times x is x squared x times b is bx, b times x is bx, and b times b is b squared. You simplify that, you get x squared plus 2bx plus b squared. Okay, so now we've got that. And I'm going to try and morph this, as I said, I'm going to try and morph this into this, right? So on this side I've got 2b, but I only want 1bx. I've got 2bx on this side, but I need 1bx, right? And the way I'm going to get 1bx is by halving this b, okay? Because then when I times it out, I'll get x squared plus a half bx plus a half bx plus b squared over 4, and then that'll simplify to x squared plus bx plus b squared over 4. Okay, so there we go. There we've got our x squared plus bx, and that's lovely. That's what we have over here. But now look at this. We've got a fishy little bugger over here, that x squared over 4. We don't want that. Okay, so let's take this, because b and c, I should have really written over here, let's just say let b and c be real numbers, real values. Okay, because b and c are real values, this is just some number, right, that we would know at the beginning of trying to solve this. But let's just minus that off at this stage, right? And if we do that, we get this, what we had before, minus b squared over 4. And then that just equals x squared plus bx. And all we need now is just the c. So then we can say that x plus a half b squared, let's just add on, we're just going to add on the c, minus b squared over 4 plus c is equal to 0. And there we go. Once you times all that out, that is equal to x squared plus bx plus c, which is what we had at the very beginning. So that means that this is equivalent to this, but this is a much more useful version, as I was saying earlier. And that is how you prove that you can write this complete the square form. It's very useful. I highly recommend it. Anyway, bonus over. Bonus complete. Sadly, we have come to the end of this epic maths video. I hope you enjoyed. Like and subscribe. Goodbye. I'll hopefully see you in the next one.